In this video, we are going to look at the airplane seat assignment probability LeetCode question. And this question is phrased in this particular way. There are n passengers boarding an airplane with exactly n seats. The first passenger has lost the ticket and picks a seat randomly. But after that, the rest of the passengers will first take their own seat if it is available and pick other seats randomly when they find their seat occupied. We have to return the probability that the nth person gets his own seat. Now, this particular question is asked in this way many like most of the times, right? We take n as 100. It's so there are 100 people in a queue, each with assigned seat. The first person in the queue is drunk. They may sit on their assigned seat or choose a seat randomly. Every subsequent person in the queue from the second person onwards follow these rules. If their assigned seat is available, they sit in it. If their assigned seat is taken, they sit in a random seat. You are the 100th person in the queue. What is the probability that you will sit in your assigned seat? So this particular question, now there are two methods to solve this particular question. So we'll just move it up. Yeah. So the first method is intuitive sense by intuition, or the second method, mathematically, we can solve the problem. So first we'll try solving it mathematically. So there are three particular cases. So if we, let's say we take n equals to 100. Now if n is equal to 100, there are three cases. Case 1, the first person sit on seat 1, right? Let's denote seats with uh, SI. So the first person sits on seat 1, meaning it's assigned seat. So in this case, we'll take our event, that is, let's say event is that we sit like the nth person, the last person sits on nth seat, meaning their own seat. That would be SN. So if the first person sits on their own assigned seat, meaning every subsequent person will come and sit on their own assigned seat, so that would mean that probability of this particular event, probability of E here, given this, would be 1, meaning we will sit on, the last person will sit on the last seat. But the probability of this particular event happening, that it sits on S1, is 1 by n, right? Now, the second case would be that the person sits on Sn, meaning it sits on the last seat itself, the drunk person. So in this case, the probability of us sitting on our last seat is obviously 0. But the probability of this particular event happening, that the drunk person sits on our seat, on the last seat, is again 1 by n, because there are n seats. Now, what else could happen? That the person sits randomly at some, let's say, Si seat, right? Sits randomly on that seat. Now here what happens, this particular case, let's say probability, the function we have to calculate is for n, right? The probability that the nth person sits on the nth seat, given there are n members. So let's calculate fn, f1. So we know if there is only one seat, then the person goes and sits in that seat, so it's 1. Now let's calculate f2. If there are two seats, then comes the drunk person can either sit on its own assigned seat, or it can sit on the last person's seat, right? So if it sits on its assigned seat, then there are like two cases, right? The first person sits on its assigned seat, and if this person sits on the second seat, so there's like a 50-50% chance that the last person sits on their assigned seat. So the probability of f2 would be 1 by 2. Now similarly, if we look at f3, you just remove this here. Now f3, so there are three seats, right? 1, 2, 3. Now the first case would be the first person sits on its assigned seat. The first person here, the second person would go here, the third person would go on the third seat, meaning the third person sits on its seat. Now, second case would be the first person goes and sits in the last seat, and the second person would take its seat, and third person would have to take the first person's seat. And in this case, the third person does not sit on their own seat. The third case, these were the two cases that we discussed above here, right? Now we have to look at this when it sits randomly on some other seat. So if the first person goes and sit on the second person's seats, now the second person becomes the drunk person, right? So now that since the second person becomes the drunk person, so it has to choose between either this and either this, and its seat becomes the first seat now. If the second person chooses the first seat, then we are able to sit on the last person is able to sit on the last seat. Else, if the second person chooses the last seat, then the last person has to sit on seat one. In this case, we are not able to, like, the third person is not able to sit on the last seat. So out of four cases, in two cases we are able to sit on our last seat. So the probability is 2 by 4 again, 1 by 2. So we can see that I mean, if we'll calculate f4, we will see it's still 1 2. Now this will make you like wonder if the probability of fn equals to 1 2 as well. So we'll try to derive a recurrence relation here, since as you can see, as we pass on, like as one sits on that particular person's seat other than the first and the last seat, then that particular person whose seat one has occupied becomes the drunk person. It's a recurrence relation. So now coming to here, now we'll have to calculate the probability. Now probability of E here, well, it depends, okay, and the probability of SI we have to calculate, and we have to apply the probability multiplication and addition rule to this statement. So let's see. So the cases, again we'll go here, the cases. Now first sits on 1 S1, right, sits randomly, but just not on S1 and Sn, and sits on Sn. So now our function would be, now sits on S1, as we can see here. We'll multiply these two, multiply these two, multiply these two, and we'll add them. So sits on F1, there is 1 by n chance that the person sits on S1, and if that person sits on S1, there is like 100% probability that the nth person will sit on its nth seat. We'll come to this later. Now sits on Sn, there is 1 by n chance that the person sits on Sn, right? But there is if the person sits on Sn, then there's 0% probability, zero chance that our last person gets to sit on their own seat. Now sits randomly, of course. Now we'll have to sum the probability of each seat it may occupy. So here we'll have to sum, starting from 2, the second person seats, to the second last person seat. Again, the probability of the drunk person sitting on their seat is 1 by n, and then we'll have to multiply it with the probability person of each person, because now that person becomes the drunk person. So we'll just, since we're taking that probability as a function, so we'll just use f here. So this is this case, this case, and this is this particular case. And now we can prove that, now we can try to solve this relation, right? So we know that this would be 1 by n. 1 by n can be taken outside. You can also take it as p of I and p of n, but we have to calculate a function, so we'll just take f, and this whole term is 0. We can take 1 by n as common, so it would be 1 plus summation. We can try expanding the summation here. Right. Now this particular value is of fn. Now let's try calculating similarly for fn minus 1. F of n minus 1. We'll write f of n minus 1 as f of f 1 by n minus 1, then 1 plus summation starting from I equals to 2. Now in the formula we see it's n minus 1, so here it will be n minus 2 and the f of I. We can try expanding it a bit as well. 1 by n minus 1. Right, now here you can see that this part is equal to this part, in the f of n equation. So we can substitute this particular part in our f of n equation from this f of n minus 1 equation, right? So we can move forward as we can bring this n minus 1 to this side. So n minus 1 times f of n minus 1 will equal to this whole term. So in our f of n equation, we have from here, this is our f of n equation. We can replace this with this, so 1 by n. Now as you can see, replacing this, we are left with plus f of n minus 1, right? So we'll add that. Here we'll substitute this whole value with this, so n minus 1 plus this was the term that is left. Now I'll try and solve this. Now as you can see, that f of n is equal to f of n minus 1 in this particular, from the that f of n is equal to f of n minus 1. This is a really important relation we calculated. Now if let's say we have to calculate the probability of 4, right? So that would equal to probability of n equals to 4, that would equal to n minus 1, that is 3, and that would equal to f of 2, which is essentially 1 by 2. So for any f of n, it would equal to f of 2, which is 1 by 2. So basically f of n is equal to 1 by 2 for all n greater than equal to 2. So this is how you will calculate the answer for this particular question. Now on to the second method. Using second way is intuition. You can see, like, let's say we have 4 seats available to us, and now the first person, if the first person sits on the third person's seat, then you can like intuitively you can say that the third person, as we seen in our previous method, now the third person becomes the neutral person, and it will have to sit on the first, and its seat becomes the seat of the first person. Now what you can do intuitively is, when the third person comes to board, like the second person will sit on their seat, and the third person, when it comes to board, it kicks out one and sits on its seat. Third person sits on and kicks out one. Now again, it is now one's now it's on depends on one whether the one will sit on the first or the last seat here. So it's again 50-50 chance. Now let's say we have 6 seats with us. The first person goes and sits on the third person's seat. The second person would come and board this. Now the third person will come, right? It will sit on their assigned seat, kick out one. Now the one person has to choose between these seats. Let's say it sits on the fifth person seats. Fourth person comes, boards their seat. Now the fifth person will come and they will kick out one again. So now the first person again have to choose from where to sit. So it all boils down again to 50-50% chance and 1 by 2 probability value for all n greater than equal to 2, because for n equals to 1 the probability is 100%, that is 1. So this is how this problem is solved. Going to our LeetCode problem here. Now it's obviously a very simple solution. If n equals to 1, then you have to return 1, else 5, 1.0. And here we are done. Now I also wrote a code for simulating this particular question. In this, we this is the number of trials we want to simulate this particular statement, and for this we randomly makes the first person's choice, and then we simulate the remaining people who randomly sits on the available seats, and then we'll check if the last person sits on their seat or not, and then we calculate the probability. So let's say our n is 100, Okay, and we simulate for n and we have the trials of like 10,000, right? So you can say the probability is really close. I mean, is 0. Really close to 0.5. The theoretical probability, obviously, if we increase the number of trials, it will get closer to 0.5. Here you see. So yeah, this is how we'll solve this particular question.